Hi everyone, today I wanted to talk you through a complete roadmap for the MERN stack. If you want to know what it is, why it is used, where it is used, how you can start learning it, more specifically how you can start learning it better than everyone else. Let's get right into the video. Also, please ignore this. Get this fixed very soon. Let me start with a disclaimer. The disclaimer is that roadmaps like these are extremely useless. The reason for that is you know what to do, but you don't really do that. So I would strongly suggest after this video ends, please try to go through these 3 videos in which I'm actually teaching the MERN stack from the basics, and we've already had 3 parts now, and I'll be adding more parts to this so that you actually start coding, actually start building projects, actually start making assignments. That's the only way to learn the MERN stack. This video will give you a roadmap, but unless you execute on it, you won't really learn anything. So full stack development is generally divided into 2 parts. It's the front end and the back end. Front end is what you see. Front end is what reaches the user inside their browser. And backend is where a lot of magic happens, but you don't really see it as an end user. So what is frontend on chatgpt.com? It's basically all of this, these 2 buttons, this input box, this button right here. All of this is what's called front-end code. And one very high level thing you need to know is this front-end code, even though it's written by developers like us, it's always run or it's always executed inside a browser. So you can effectively you basically give this code out to the end user. They can actually see this code because this code needs to run on the browser. That's the only way for you to render a screen like this. The backend code, however, the backend code basically is all the functionality of the website, which is basically what happens when I click on this button. What happens when I ask ChatGPT a question? How is it able to decode things? And how is it able to give me an answer? All of that does not run on your browser. It runs on a device somewhere else out in the world. It usually runs in data centers like these, and that is code you never see. That is code I can never get access to. Whatever happens in the backend, whatever converts this prompt into an actual answer, I don't have access to as an end user. But this website's code, how this button looks like, the CSS for it, I can see as an end user if I do a little bit of magic. Cool. Front-end code, back-end code. Front-end runs inside your browser and back-end runs on some data center out there. So let's start with front-end. How do you write front-end code? How do you write the code for a website that looks something like this? In the pre-React days, which means for a very long time until 2010, the only way to write something like this was using raw HTML, CSS, and JavaScript. So these are 3 languages you need to understand what they do and how they work. You also need to get a little comfortable with their syntax. I would spend at least a day or 2 on HTML and CSS, and at least 3 to 4 days on JavaScript just to understand its syntax and how you can do basic websites using just this stack. Nothing too complicated. HTML, CSS, and JavaScript is enough to build any website that's out there, but there are better ways to do it now, which is why React was introduced. But up until 2012, when a lot of front ends were built by some really smart people, they were done in raw HTML, CSS, and JS. There were some other frameworks, but React came into the picture and sort of killed everyone else, and React is the primary framework now. But up until this point, for the first iteration of a front-end website of yours, just use HTML, CSS, and JavaScript and try to build a website. The important thing here is JavaScript. JavaScript was a language that was introduced because people realized if you want to build a website, it needs to have some functionality. You're at ChatGPT, a button click should have an on-click handler. If I click on this button, something should happen that changes what this screen looks like. To do all of this, you need a scripting language that your browser can understand. And in 1990s, they realized that, okay, we'll put out browser as a primitive out there. Anyone can build a browser as long as your browser can understand these 3 languages. The most important one here being JavaScript, because JavaScript lets you do a bunch of things. HTML and CSS just lets you visualize a website, which is also important. But the core functionality is written in JavaScript. JavaScript, which was originally introduced just to be run inside a browser, eventually people realized it's a scripting language. It can be used for backend stuff as well. What is backend stuff? Basically, code that runs here. And people sort of extracted the engine that understands JavaScript and put it out into a new framework, which is called Node.js. Not really a framework, it's what's called the runtime. But effectively, whatever used to run JavaScript inside Chrome, whatever that engine was, people went into the source code of Chrome, extracted just that part out and said, hey, JavaScript does a bunch of things inside the browser, which is cool. But now we have that engine, you can do a bunch of other things with JavaScript as well. How? Through this runtime called Node.js. So the MERN stack, N in the MERN stack stands for Node.js, which is a runtime that lets you run JavaScript in the backend. Why is this new and why is this exciting? This is exciting because for the longest time, JavaScript was only meant to be run inside the browser, which means it was only meant to be run on the end user machine, which is your machine, my machine, not the developer's machine. These data centers that we talked about, JavaScript was never really meant to be run here. But people realized that it's a very powerful language, sort of slow because it was originally implemented for browsers. But people thought, hey, a lot of JavaScript developers exist. Why just restrict them to the front end? Let's make them do backend stuff as well. And Node.js was introduced. Again, you can't run HTML or CSS in the backend, only Node.js, more specifically JavaScript. Okay, so what is backend in the MERN stack? Basically, you need to understand Node.js, and it looks very similar to JavaScript, which is why it's like not very difficult to understand it. But there's like a mild shift when you're moving from browser JavaScript to Node.js in the backend, because the backend Node.js does not have a lot of browser constructs, which your frontend did. We'll come to that later on. Effectively, it's a very easy sort of path to move from JavaScript in the browser to Node.js in the backend. Once you've done that, once you can run a few basic scripts in Node.js, comes the most important part, it being HTTP servers, and more specifically Express. Express is what the E stands for in the MERN stack, and this is what lets this machine that's out there in the world talk to my browser. My browser that exists on my machine here in India can talk to a ChatGPT server in the US because of this protocol called the HTTP protocol. And the way to implement that protocol is building HTTP servers, which in case of the MERN stack is using Express. So what is Express? Express is an HTTP framework, and if you want to understand this better, go through the first part of the roadmap. But Express is a framework that is written in Node.js that lets you create an HTTP server, which is used by browsers to talk to your backend machine. So if you have a data center out there, if you have a machine out there and you want to access it from any place in the world, HTTP is one way to do it. And most websites that are built out there, their backend is usually an HTTP server. That's how your browser talks to it and interacts with it. Cool. The second important thing that a backend like this needs to do is store data. When I go to chat.openai.com, I have this section on the left, which looks something like this, where all my existing chats are stored. It also knows who I am based on when I've signed up. And all of this data, basically my first name, my last name, all my existing chats, need to be stored somewhere. And databases are one way to do it. You could do it any way. You could like basically open a file on a backend server and store all your data there. But databases make it easier, which is why they were introduced as a construct, a place where you store all your data. And there are multiple types of database, all for various use cases. So there are two broad categories you can break a database into, SQL and NoSQL from the very high level. SQL databases are slightly more structured, used in more proficient applications that need your data to be very strict. But if you're just starting out, you want to build a hackathon project, NoSQL databases are slightly easier to understand, and it doesn't take as long for you to understand them. More specifically in the MERN stack, M stands for MongoDB. MongoDB is a NoSQL database. So if you want to specifically learn the MERN stack, you have to go with NoSQL. Cool. Next part. We know HTML, CSS, and JavaScript, and we know HTTP servers now. We can build a basic website, both front end and back end. But this is like not the right way to build websites, because it's like very hard to build a complex website using just HTML, CSS, and JavaScript, which is why you need a front end framework. These frameworks were introduced because HTML, CSS, and JavaScript weren't enough. And in the end, what these frameworks spit out are also HTML, CSS, and JS files, but they make it very easy for developers to build these, which is why these have become so popular. Like React developer in itself is like a job title, because you no longer want to write raw HTML, CSS, and JavaScript. You want to use a framework like this to make the life of a developer easy. More specifically, if you want to build complex frameworks, the only way it can happen in a big company with multiple people writing code is through a framework like this. There are other frameworks as well, but React is the most famous one. So here is where people get stuck a lot. Here is where people sort of aren't able to move from raw HTML, CSS, JS to a React project. This is probably the most difficult part. You can see this in my series as well. The first part, the assignment was done by more than 300 people. The second assignment, which is the React assignment, was done by less than 50 people, because harder to understand React. It's much easier to understand HTML, CSS, and JavaScript and basic Node.js. Cool. So spend a decent chunk of time here. And React or general front-end frameworks are usually broken into two parts: components and state. Components are state. Without getting too deep into it, React sort of introduced this concept of components, which is what makes lives of front-end developers easier. Basically, a chunk of code that can be reused across places. For example, if you go to Instagram.com, all the posts that you see there are a component. The sign up button is a component. All of these are small components that are built independently and can be reused. React sort of makes that easier. The second important thing is state, which is basically more specifically what your website looks like. So components are what a generic image post looks like. State is, okay, for Harkirat, what are the 10 image posts that should appear in a simple array? It does not have to be HTML, CSS, JavaScript. Storing the complete state of your application in a simple data structure is what state provides you. And components, basically a way to render everything based on your state. So two parts, components and state. Spend like a decent chunk here so you understand front-end development in React. Once you've done that, important thing is connecting front-end and back-end. It's easy to build HTML, CSS, and JavaScript front-ends. It's easy to build Express back-ends. It's easy to understand, well, sort of easy to understand and build a front-end in React. But you eventually have to connect these two. If you go to chat.openai.com, when I click on the button at the bottom, sends a request. It goes to a backend. Backend returns something, and then I render something new on the screen. All of this process is like a day or two worth of work where you understand, hey, this is how a browser application interacts with the backend. Once you've done that, you need to deploy it on the internet. It's easy to do these things locally, but eventually if you want people to use it, and more specifically, you'll have like a lot of dopamine hit if you deploy these things on the internet, which is you host them on chat.openai.com or your own domain name. Like buy a domain name on godaddy.com, buy a server, deploy a code there, and then make sure your code is available on the internet for everyone to run. That's like a decent lift. Understanding that, once you do, you should understand containerization without getting too deep into it. It's basically the way apps are deployed, and more specifically, backend apps need to be deployed. Once you understand containerization, you need to understand auto-scaling. One server is not enough. You need a very big data center, and the number of machines that are running your backend code need to go up and down. Only then will your app actually scale to millions of users. Else, it will be running on a single server, which, well, if no one is using your app, it's great. But effectively, your goal is to build websites that people use. And when people use websites, the load increases, which means you need more servers. Which means during the peak time of IPL, increase the number of video servers. As IPL goes away, decrease the number of video servers. You need this to be cost efficient. At the same time, you need to make sure you can handle load and spikes. That's what auto-scaling teaches you. Once you understand that, you need to understand things that are more than HTTP. Most websites, I have a strong feeling that this will happen. Eventually, businesses will have some moat. They currently do as well. If you go to any of these websites, they have some moat. Moat being something that they have which is more than your client interacting with a backend and your backend doing some basic stuff. Lead code lets you run any code of any language on their backend servers. This is not something that HTTP will teach you or like the MERN Stack will teach you. This is slightly more than building websites. YouTube has a very strong video pipeline, transcoding videos, going live, sending live videos to millions of users. All of these are something that are usually not part of HTTP or more specifically MERN Stack, but this is how you differentiate yourself from other people. Eventually, when you understand the MERN Stack and you can build simple websites, you'll have to go into businesses. Like businesses will have some moat, and building the website is easy. Building these moats are hard. So you need to get into more complicated backend technologies. Swiggy, for example, has like a map feature or a tracking feature where in real time you can track the driver. A lot of these are outsourced to Google Maps, but you want to build this in-house, like a pretty decent moat for a business. GitHub lets you store your code on the cloud and basically share it with everyone. It's a very nice UI for your version control, and hence also a decent moat that they have, which is more than HTTP. Zerodha is a trading application. I don't even have to explain it. Not easy building an application like this, and hence these are things you need to get into eventually. But until you get there, first you need to understand how you build basic websites, basic backends, basic frontends, and databases. For that, MERN Stack is great. The only way to run it, I think, is doing projects and contributing to open source. There are 1,000 tutorials out there on the MERN Stack. I have created them myself, but unless you do the assignments in my roadmaps, you won't get anywhere. Unless you create your own projects, you won't get anywhere. Best way to do that is either do your own projects, do assignments, code, push them on GitHub, or contribute to open source. Basically, find projects that are already out there, that are built by real developers, that have a bunch of issues, fix those issues. Only then you know that you actually understand the MERN Stack, when you can contribute to other people's code. When you're joining a company, you're probably not bootstrapping the application from the basics. There is an application out there, you're solving bugs there. So the only way you know you understand the MERN Stack and you're comfortable with it is if you can contribute to open source projects or like build projects of your own. So strong suggestion here, find open source projects in the MERN Stack, contribute to them. Cool, that's the end of the video. That's a decent roadmap. Again, go to Full Stack Roadmap Part 1, 2, 3, try to solve them. If you want more specific guidance, join my live course that is starting from 9th of June, where I'll be teaching all of these things from scratch from 9th with a lot of assignments. Saturdays and Sundays will be grinding it out and understanding these concepts from the basics. Again, I've given the roadmap, this is what I'm teaching. You can do it yourself as well. No hard feelings. If you want to learn it with a community, with me, by me, join the course. There'll be a lot of assignments and it'll be sort of very hardcore. The second part of the course is going to be understanding open source projects so that you don't have a very high level, surface level knowledge of the MERN Stack. You have enough knowledge to go into code bases and solve issues there and maybe get hired. So that's the gist of my course. If you want to join, great. If not, this is the roadmap. Follow it. And I hope you become a master, at least the top 5% in the MERN Stack. Guys, let's end the video. I'll see you in the next one. Bye.